slug, or whether the slug is followed by any other small drop. So that is tutorial of this course. And in this tutorial, we are discussing about the flow pattern. So we have two setup. One setup is of this glass capillary. Okay, its diameter is 2 mm, length is around 60 centimeters, and we have two fluids. One is water. So this is the pump. This is the peristaltic pump for water, and this is the pump for solvent. Okay, so this tube is firstly washed with ethanol, then air dried, then we are using it. On top of it, you are seeing a box which is a view box. This box is filled with glycerol in order to prevent any distortion of the images which are we are going to take. So this is the camera, high-speed camera through which we are taking the images, and this is the backlight we are using. So what we are doing, we are keeping this flow rate constant, and we are trying to either increase or decrease the second flow rate of the second phase. So what you are visualizing over here is different flow patterns. So this the continuous phase over here is water, and you can see the flux of toluene. So now the flow rate of toluene is maintained at 2 ml per hour, right? And I guess all of you have noted down the slug. So you can see the slug, there are small, tiny slugs. Okay, and in between, you can see very small drops. Okay, you can see the spherical drops also, they're traveling. So this particular thing is not entirely slug. It is also some kind of, you can see in between two slugs there is a gap. In between two slugs there is small broken slug. In between two slugs there is small drop. So this is not what we call is consistent flow, but it is kind of some transitional flow. It is not a slug that is well developed. Okay. So now we are going to increase the flow rate of toluene, and let us see what will happen. So now the flow rate of this toluene is increased to 3 ml per hour. So you can see, you may notice there are long slugs we can see in between. In between there are, of course, the transition region is going on, but there are well developed slugs. You can see this one is developed, and this is kind of broken drops. Okay, so the slug that is being introduced is, you can see from here that they're injecting, and at the tail they're broken up, and that is why the drops are formed. And this broken drops are actually forming from the tails of the slug due to the interfacial, high interfacial force. Okay, so that is what it is happening here. You may visualize the same thing to this camera. Okay. Change it further. This is the flow rate. So what we have done, we are now keeping the toluene flow rate constant, and we just reduce the flow rate of water to 3 ml per hour. Okay, so you can observe the flux now. Yeah. And tell me what you are seeing. What is the change, or is there any change?
Small slugs are forming, not a droplet. There are no more technical droplets. All are the elongated slug bed.
So it's kind of droplets are dominant. This is a mixture of slug and Okay, so in your tutorial sheet, the full statement, I guess all of you more or less noted down what we have done for the toluene and water, the horizontal capillary, for different combination of fluoride. Now you can go back to your seat and you can just sum it up for different volumetric fluoride, whatever readings you have taken. Okay. Then we will again repeat the experiment with 1 ml. Then you realize what is the change of the characteristic flow pattern that you have taken. Okay, so you can look at this box. This is actually in between. Okay. The flow is basically developed when it is coming through this view box. Okay. At the entry and the exit, you should not see the flow pattern because it is influenced by some either entry effect or exit effect. So you may check through this camera how they are looking, whether their characteristic is same or they're going to some different. So all of you have noted down? Yes? We will sum it up, then we will call again for another session.
Dr. Miss Navneeta, Dr. Dheeraj, Yam, Dr. Lokesh, and Dr. Khan.
We will note down what is the flow rate of water and solid.
We started the reverse and we will not be able to regulate. Then also that will form.
Because it is a hydrophilic gas. So whenever the water enters, it weights the fine oil. Solvent is always form dispersion in such kind of a thing.
Even if it is in the
So in the entry effect, you may see something flow is developing, but when the flow is developed, it is always the solvent or the dispersion.
and this light is not heating this.
Is well kept in a distance and covered.
Look, we have to don't have to use slightly like this aspect. Otherwise it will become a process.
That is the entry.
Yes.
Here is the this.
So then here something a dominant system with the knowledge. So that is had a flip. Dominant system with the knowledge. Because it is system.
Something what happens is there is some dirt or some
Yeah, yeah.
accumulation, and that is why we need to clean it repetitively. Okay. So maybe some dirt is inside. That is what it is happening. Locally it is sticking, then it is coming.
So should we put this entrance smaller as possible or should it be right now for demonstration purpose it's like this. Normally it should be as near to
No, there is a thumb rule that where we should take the reading or observe the flow pattern, that should be at least minimum 50 L by distance, 50 D distance.
for developing.
Yeah, more you take, the more it will be giving you the authentic result at the development. So in any case, we are not considering the entry effect, so we are not considering whatever flow we are observing over here. We only consider the flow when it is developed, and there only the view works is based.
When we increase the water flow, the surfaces are small, the length of it.
Smaller. So you can change it yourself and you can check. So this is now the water is at 3. Okay. So if we can increase it, increase the water velocity to 5, you may check what happened to the slug.
Very small.
You may note down the characteristic, or you may also note down whether there's slug at all, or whether it's a mixture kind of a flow regime where you can have unstable flow regime, or you can say transition type of flow regime where you have stable and followed by some.
Is it possible to whatever starts from here has a different once it reaches after a distance? The gap between two drops of after cutting.
It may happen if it is also we have seen that two drops either they are joining or a slug from the tail it is breaking up. But to happen that inertial force needs to be higher, or you have some kind of instability that is going that is breaking the slug from the tail end. So what you are saying that is possible that we have observed that has also happened in the scan. It is possible, but it is more likely when you have a disturbance in the flow.
I mean, immediately as it moves, whatever is coming here should have come here and should have come here.
Whatever is coming here, they need to be developed. Okay, these are not developed yet. So
Development in terms of shape.
in terms
So
of
the
shape.
gap will remain same.
So when it develops, there may be the gap is little bit here and there. Might change also.
Okay.
Okay. And if there, you can see if there are small bubbles, they can join also and form a big bubble.
Big one.
That is why we are taking the observation over here.
So for the stable flow, after that 50 L,
Yes. We consider
it should not change theoretically.
theoretically.
Even if it is going longer to that, it should still have the
That
same
is-
distance, same shape.
Right, right. That is what we assume.
Okay. But it may change in certain places.
We will see that also.
Okay. Okay. There, the tricky part is where to place it. Sometime.
And sometimes you need to place it or not on single part, but
Multiple parts just to see how is it taking with the distance.
Okay, next group then.
Ilyas, Pankaj, Manoj, Adar, and Rohit.
This is what is the So that everybody can see.
भैया प्रोजेक्ट नहीं रीडिंग दिखाएंगे
So, have you understood the different? Have you seen the changes of two fluids? Change of fluids. What fluid? So you can see what happened, how the characteristic changes when you increase the fluid of water to 3. Okay, initially it is 2, now we have increased the fluid of the continuous phase. Following here, green color is the dispersed one. So you can see any changes? Anyone? Okay, maybe next group. Have you noted down the changes with fluoride? What is the characteristic change in the slug flow? Drops. So you will look at the camera recording what is being shown. The flow is going develop flow or it is develop and The flow pattern is, can you say it, sir? Look at the camera, it will give you a better picture. Okay. Okay, let's take your seat, write your observation. We will again repeat this with one. I think we can replace we have one group left, right? The rest of the group, you may join now.
Pratyusha, Neema, Sanil, Satish, and Sohit.
Sunil has already been seen. Pratyusha, Neema, Satish, and
Sohit.
Sohit.
और कोई तो नहीं बच रहा.
Let's look on this camera also.
ट्राई कर रहा है.
This is for toluene. This is for toluene. The pink one is for toluene, and this is for water. What you are observing is water continuous, and in space of water there are small stubs of toluene.